So if I go for question number 11, a simple pendulum of length L and mass m is oscillating about a vertical line like this with angular amplitude theta. This is very important point, amplitude. For an angular displacement phi is less than theta, you have to be very careful this point. The tension in the string is T1, and for angular amplitude theta the tension is T2. Then we need to calculate the relation between these two. So first I am going to make the situation for amplitude theta. This is, so this angle is theta and this angle is theta, and this is the mean position. So bob will oscillate like this. In this position, if I resolve the component of the weight, so this is mg cos theta will act in this direction and mg will act in downward direction. There is another component of weight, that is mg sin theta. Length of the string or pendulum is L. So this length will play the role of radius and the direction of tension will be here. But along with the direction of mg cos theta, यहाँ पर एक और फोर्स होगा जिसको हम लोग लिखेंगे mv स्क्वायर बाई L, राइट। अब देखते हैं, इस प्रॉब्लम में ये एम्पलीट्यूड थीटा दिया हुआ है. एम्पलीट्यूड मीन्स मैक्सिमम डिस्प्लेसमेंट फ्रॉम मीन पोजीशन. So if I consider the point A is the extreme position, so in this position the speed V will becomes 0. Similarly on this extreme position speed V will becomes 0. यानी कहने का मतलब ये है कि जैसे ही ये मास मीन पोजीशन की तरफ जाएगा स्पीड इंक्रीज होगी क्योंकि मीन पोजीशन पर मैक्सिमम स्पीड होती है. कहना मैं ये चाह रहा हूं कि इफ आई कैलकुलेट द टेंशन एट पॉइंट ए एंड दैट इज रिप्रेजेंटेड बाय 2, सो दैट इज ओनली mg cos थीटा बिकॉज देयर इज नो स्पीड. बट अगर मैं बात करूं फाई के लिए, एज पर द क्वेश्चन फाई इज लेस देन थीटा. लेस थीटा मीन्स आपको जो मास का पोजीशन लेना है वो एक्सट्रीम पोजीशन से थोड़ा पहले लेना है. यानी जब एज आई डिस्कस्ड इट विल मूव टुवर्ड द मीन पोजीशन देन स्पीड विल नॉट इक्वल टू 0. सो in this case you will write the tension T1 and T1 is mg cos phi plus mv square by L is there, because in this situation speed is not equal to 0. तो हम लोग देख पा रहे हैं कि T2 में there is only mg cos theta, but in the case of phi there is mg cos phi and mv square L will be the additional part. So by this observation we can say that T1 is greater than T2. So my option number 1 is correct. So let's move on question number 12. So now I am going to read the question number 12. A block of mass 20 kg is set into motion on a frictionless horizontal surface with the help of massless smooth pulley and rope as shown in figure. Find the acceleration of the pulley. So if I go for the FVTs of this, so we'll see, because this is the fixed point, so we can observe the force is 100 Newton जो क्वेश्चन में दिया है, and this force will be F by 2, and this is also F by 2 by this diagram. So we are saying that if I go for the acceleration of this block, so we'll write net force F by 2 upon mass. So F by 2 means force will be 50 Newton and mass is 20 kg. So we'll see the value of acceleration is 2.5 meter per second square, and this is the acceleration of this mass or block. But I need to calculate acceleration of the pulley. So you can observe this by using, if I consider the displacement of this pulley is only x from initial position. Then we'll see the displacement. If I consider the displacement of the block is only y, we can say that by this, मैंने यहाँ पे कंसीडर किया हुआ है कि अगर मैं पुली को x डिस्टेंस मूव कराता हूं तो इधर से स्ट्रिंग ये भी x मूव करेगा, ये भी x मूव करेगा, तो वी कैन राइट y इज इक्वल टू 2x, राइट. So if I go for the displacement of x, we'll see by 2, half of the displacement of the block. So by this observation we can say that if I go for the acceleration of the pulley, so this acceleration will be half of acceleration of the block. So we'll write 2.5 divided by 2. So my final answer is 1.25 meter per second square, and this is the acceleration of the pulley. So my option number 2 is correct. So let's move on question number 13. So now I am going to take the question number 13. In a simple Atwood machine, two unequal masses 5 kg and 2 kg are connected by a string going over a clamped light smooth pulley. Now a constant force F1 is applied on each mass in vertically downward direction. The ratio of acceleration of either block before and after applying the force will be. So this is the diagram. Suppose this is the situation of pulley as per the question, and first mass is 5 kg and the second mass is 2 kg, and before applying the force, if I go for the acceleration A1 before applying force, so A1 is given by difference in weight 5g minus 2g upon total mass as per the formula of acceleration. So we'll get 3g upon 7. And now according to the problem, if I applied a force F is equal to 1 Newton in downward direction, similarly on the block number 2 1 Newton. So if I go for acceleration in this condition, so then I need to calculate the net force or difference in weight. So will becomes 6g minus 3g upon 5 plus 2 total mass. So that will give you once again 3g by 7. So if I go for the ratio between these two, you are saying that 3g upon 7 दोनों में दिया हुआ है, 3g upon 7 and 3g upon 7. So when you will go the ratio, will get 1:1. So my option number 3rd is correct. So let's move on question number 14. If I go for the question number 14, a car goes on a horizontal circular road. Let's suppose this is the horizontal circular road. Radius is r. The speed of car is increasing at a constant rate a meter per second square. So this is the value of tangential acceleration. If the friction coefficient between the road and tire is mu, then the limiting speed of the car. Limiting speed of the car यानी मैं बात करना चाहता हूँ safe motion के लिए. And you know, when car is moving on a circular track, then this car will experience a centrifugal force on the opposite direction. And for the safe motion, friction force should be equal or greater than mv square by r. और you know, जो यहाँ पे फोर्स होगा ये F है, और जो लेफ्ट हैंड साइड में फोर्स होगा वो फ्रिक्शन है. बिकॉज कार हैज ए टेंडेंसी टू स्किड और स्लिप हो सकती है राइट साइड में, तो टायर और रोड के बीच में एक रिलेटिव मोशन होगा जिसका टेंडेंसी होगा राइट साइड में, और फ्रिक्शन फोर्स रिलेटिव मोशन को अपोज करता है. सो दैट इज द सिनेरियो. द डायरेक्शन ऑफ फ्रिक्शन फोर्स विल बी टुवर्ड द सेंटर, एंड फॉर द शेप मोशन विल राइट friction force will be greater or equal to ma, where a is the net acceleration. So first I need to calculate this acceleration, net acceleration I mean to say. So net acceleration is calculated by centripetal acceleration, which will act toward the center, and another acceleration is tangential acceleration, right? So first I am going to calculate the centripetal acceleration, that is given by v square by r with the square, and I need to calculate tangential acceleration, and tangential acceleration is given by dv over dt. But question says increasing at a constant rate a, so that is a. डायरेक्ट आपको दिया जा रहा है कि a मीटर पर सेकेंड स्क्वायर. सो द वैल्यू ऑफ नेट एक्सेलरेशन इज v to the power 4 divided by r square plus a square. So this is the value of net acceleration. And if I use the value of net acceleration in equation number 1, so now I am going to use from equation number 1. First I am going to write the value of friction force, mu mg greater or equal to ma, the value of m, and I need to place the value of net acceleration, that is root b to the power 4 upon r square plus a square. So mass and mass will cancel out. I need to calculate the value of v. So on solving we'll get v is equal to mu square g square minus a square multiplied with r square, because v has the power of 4, so there will be 1 upon 4. So final answer is mu square g square minus a square whole multiplied by r square, and whole power is 1 upon 4. So my option number 1 is correct. So let's move on question number 15. If I take question number 15, 1 kg particle strike a wall with velocity 1 meter per second at an angle of 60 with the wall and reflect at the same angle. Because angle is same, so we can take speed will remain the same. This angle is 60 degree and this angle is 60 degree. So this is the initial speed u. If I resolve the component of this velocity, so we will take this angle will be 60. So we can write this velocity along y-axis is u cos 60, and this velocity along x-axis, that is u sin 60. Similarly, if I resolve the component of velocity in the case of reflection, so if this angle is 60, so this angle will be 60. यहाँ पर मैं लिख सकता हूं कि this is the value of u sin 60 and this is the value of u cos 60, because I need to calculate force, and question says the time of contact is 0.1 second. So we'll write the delta t is time interval is 0.1 second, time of contact. So I need to calculate force. So you know that the change in linear momentum with respect to the time will give you the force. So first I need to calculate change in linear momentum. For the calculation of change in linear momentum, we need the change in velocity. And you know, if I go for change in velocity, so we'll write final velocity vector minus initial velocity vector. Final velocity vector is, this is along x-axis, so we'll write u sin 60 I cap. This is the final velocity vector, but the direction of along negative x-axis, so we'll write minus u sin 60 I cap, and that will act negative y-axis, so this is minus u cos 60 j cap. This is the final velocity vector. And if I go for initial velocity vector, so this is the component along x-axis, so we'll write u sin 60 I cap positive, and u cos 60 आपको यहाँ दिखाई दे रहा है माइनस में है, क्योंकि नेगेटिव y वाली डायरेक्शन में है, तो हम लोग यहाँ लिखेंगे माइनस u cos 60 j cap. तो जब आप इसको सॉल्व करेंगे, व्हेन यू विल सॉल्व, विल गेट द चेंज इन वेलोसिटी इज -2u sin 60 I cap only, and this is the change in velocity. If I go for the magnitude, so we can ignore this negative sign. So now if I use our equation number 1, because we need to calculate the force, so first I will write the change in linear momentum, and we have the change in velocity. अगर मैं mass से multiply करूं तो will get change in linear momentum. So we'll write change in linear momentum is 2, m is the mass, u sin 60, and I'm going to take magnitude, so there is no need of I cap. Divide by the time interval, that is 0.1. So on solving, we'll get 10√3 Newton. So this is our final answer. So we can say my option number 3 is correct.